Hello, everyone. My name is Larry Rowland, and I'm the Sustainability Market Manager for Heidelberg Materials. I'm glad to have this opportunity to discuss Heidelberg Materials' carbon roadmap, which outlines the steps we are taking to reduce our environmental footprint and to use technology to deliver sustainable solutions. Many of you will be familiar with our legacy brands, including Lehigh Cement and Lehigh Hansen. Beginning of January in this year, 2023, our new brand, Heidelberg Materials, unifies those businesses under a single banner. In this way, we will better serve our customers and focus the efforts of our approximately 9,000 employees in North America. Heidelberg Materials is well known for its commitment to sustainability and investing in environmental responsibility. We at Heidelberg Materials North America are proud to be part of new ACI's Center of Excellence for Carbon Neutral Concrete. As with any journey of significant impact, it's important to have a map to establish landmarks and goals and to set a course. At Heidelberg Materials, we aim to be the industry leader on the path to net zero concrete. So we've established our carbon roadmap that lays out our plans to get to net zero concrete. Here at Heidelberg Materials, we're taking a multidimensional approach to bringing sustainable solutions to market. This approach is reducing our carbon footprint and puts us on the path to net zero concrete. We are using innovative products, including low carbon cements and supplementary cementitious materials, and embracing new technologies which provide insight to the fresh and hardened properties of concrete as it's delivered to a project. These technologies supply data which can be leveraged to support performance specifications, which reward innovation in concrete products. We are also embracing the circular economy, which incorporates reclaimed and recycled materials and reduces the impacts associated with using virgin raw materials. We are investing in carbon capture, utilization, and storage technologies, which will ultimately lead us to a net zero cement and thereby to net zero concrete. And finally, we are working with others to help define natural carbonation and account for this important aspect of concrete's natural ability to uptake CO2 from the atmosphere. Any discussion of the carbon associated with concrete needs to address the embodied carbon of the cement binder used in the concrete mixture. The primary factors that dictate the global warming potential of a given cement is the amount of Portland cement clinker incorporated into that cement. By reducing the clinker content in our cements, we are able to reduce our carbon footprint. Heidelberg Materials Ecocem PLC is a Portland limestone cement which incorporates up to 15% underground limestone with the Portland cement clinker. Our Ecocem Plus includes both supplementary cementitious materials and limestone to further reduce the clinker content in the cement. These cements meet the same stringent performance requirements of Portland cement, but with a much lower carbon content. In this way, these cements will produce concrete with a global warming potential without compromising strength or performance. Our low carbon concretes give our customers choices in carbon reduction in their mixes. Our ready-mix EvoBuild low carbon bronze concrete reduces the carbon content below a stated baseline by 30 to 50%. EvoBuild Silver further reduces the carbon content from 50 to 70% reduction. EvoBuild Gold gives you a 70 to 85% reduction, and our ultimate goal is EvoBuild Zero, which will have essentially no carbon footprint associated with those mixes. Another innovative approach is to utilize real-time tracking of ready-mix concrete as it leaves the concrete plant all the way to the construction site. This technology uses a probe within the mixer drum, which ensures that the concrete ordered and batched will arrive on the project site without any changes being made to it. It monitors temperature, water content, and the rheology of the mix to ensure that the mixture as it is batched will be delivered to the site. It also provides real-time tracking and enables the user, the contractor on site, the engineers, anyone involved with that project to know what they're getting delivered and when. Once the concrete is placed, the iCheck option supplies in-place real-time monitoring of the concrete. Internal sensors take advantage of what we know about concrete through isothermal calorimetry curves to give us real-time strength gain data so that users know how strong their concrete is on site in real time. Carbon capture and storage is a new technology that's been proven in the petroleum world, but has never been used in the concrete industry or the cement industry until now. We are proud to be the first company to install carbon capture and storage on an industrial scale at our Brevik, Norway cement manufacturing facility. This will be the world's first full-scale carbon capture and storage project. This job, or this project, I should say, will capture roughly 50% of all the emissions generated by our plant in Brevik. We expect this project to be operational in 2024, and once it's dialed in and running at optimal levels, we expect it to capture up to 400,000 tons of carbon each and every year, which will be permanently stored, thereby reducing their carbon footprint by half. On the heels of this, we have a project coming up in Edmonton, Canada, which will be a full-scale carbon capture and storage project, where we'll capture over 95% of all the total emissions associated with the cement plant. This project should account for 1 million tons a year of carbon captured and stored and permanently sequestered. This will ultimately lead to a carbon negative cement because we're utilizing biomass and alternative fuels, and the storage of that CO2 thereby reduces the carbon footprint to a great degree. I'll show you that more in the following slides. So what makes Edmonton project so special is that it's going to be the first net zero cement without having to purchase carbon offsets. The carbon capture and storage system, as I said, will be capturing 95+% of all the CO2 from the cement generated at the plant, and also from the on-site combined heat and power plant. This combined heat and power plant will serve the local community for Alberta electrical consumers and supply the cement to the plant. The emissions from the power plant are going to be fed through the system so that the carbon associated with generating that power is also captured. This, of course, will also benefit the plant because it will be highly efficient and have improved air emissions and less freshwater consumption associated with the production of the cement. This is a bit of a busy slide, but it does show the essential flow of material and the carbon capture strategy in a graphical representation. One key element to understand is that the cement produced at our Edmonton plant will not change. It'll essentially be the same material that our customers are used to. It will have the same performance characteristics as what they're currently buying. The difference will be in what happens to the gas stream. What happens to the emissions from the plant will change, even though the cement remains the same. So, in addition to the cement plant being on site in Edmonton, we will also have a combined heat and power plant. This combined heat and power plant will supply energy to the cement plant, but it will also supply energy out to the grid for local Alberta consumers in that area. Both the emissions from the plant and from that combined heat and power plant will be captured and sent through the CO2 capturing technology. CO2 is removed from the gas stream or the emissions from the cement plant and the combined heat and power plant in a CO2 absorber. That CO2 is then deabsorbed so that it can be pressurized and injected into the ground for permanent storage. The remaining portion of the emissions, the gas stream, other than the CO2, will be released into the atmosphere. Those of you familiar with the stages of a life cycle assessment chart will recognize this chart as it lays out the carbon impacts for stages A1 through A3 at the cement plant. As you can see, the CO2 emissions associated with picking up our raw materials and using that to manufacture the cement are very low. The main impacts are in the cement plant where we heat up our limestone and produce process emissions when the CO2 is released from the calcium carbonate we need to make our Portland cement clinker. Those emissions will be captured, and the fuel for the plant will use biomass and biogenic CO2 storage. Essentially, what we're doing is we're taking a biogenic material, which would otherwise release methane into the atmosphere, which is a plus carbon emission. We pull that out of the system and use that for fuel. And then we capture the CO2 generated from the burning of that fuel. Therefore, we essentially are getting a negative impact to that, to where we're actually removing CO2, more CO2 from the atmosphere than we're generating through the burning of the fuel. So we end up with a carbon negative cement that is shipped to the concrete producer, so that the concrete producer, with their emissions associated with their production of concrete, end up at a net zero concrete. An important feature of the carbon capture and storage technology is very specific geological formations that ensure that the carbon that is injected into the ground will stay there forever or until it's tapped for some purpose. The CO2 is stored in very deep saline reservoirs that are 1.5 to 3 kilometers deep in the ground. It is also imperative that there be layers of caprock that seal off that stored CO2 so that the gas will be trapped in the ground. Current global storage capacity is over 40 million tons a year, with that capacity growing as this technology becomes more commonplace. This is an established technology that is proven to work and proven to sequester CO2 permanently. In addition to carbon capture and storage, we're working to account for concrete as a carbon sink. We're joining with a host of organizations and other individuals to better account for the CO2 that's taken up by concrete as it is exposed to the atmosphere. All concrete will carbonate at its surface unless it is coated or otherwise removed from atmospheric conditions. Concrete will take up anywhere between 3 to 15% of CO2 associated with the cement production. Certain concrete, such as concrete masonry units, which are unreinforced block, can take up much higher percentages. We're working hard to account for this uptake and to quantify it and to document how much CO2 is picked up and how much can be accounted for in the sustainable life cycle assessments. Finally, we're embracing the circular economy. In addition to using supplementary cementitious materials such as coal, ash, and slag, concrete itself is highly recyclable. There's many paths that can be used at the concrete plant to either recycle or reuse comeback concrete, or to break it down and reclaim the mix components for further use in additional mixes. Return concrete can be turned into super blocks, concrete blocks that are perfect for retaining walls and other applications. It can be broken up and turned into recycled concrete aggregate, or it can be run through a reclaimer, which actually washes the aggregate, producing clean, reusable aggregate. And then that processed water can be reclaimed and also used in further concrete mixes. It's important that we embrace the circular economy to reach our carbon net zero targets. Thank you for your time. We look forward to working with you to help improve the environment and the built environment as a whole. Heidelberg Materials is committed to the future with low carbon, net zero concrete, and we welcome your involvement along that path. Thank you very much for your time.